Oh, wait, I have to go back to where we were. All right, so the first thing that we're going to talk about is a mixture problem. And basically, there's some nice notes there for you on how to solve a mixture problem. And these are all like classic types of problems that you'll see at some point in your mathematical career, in this class, and then probably in other classes, and then on standardized tests and things like that. So it's important to know how to do them. Okay, but Mrs. Voss picked up this very nice worksheet with steps of how you solve these particular types of problems. So a chemist has one solution that is 50% acid. She has another solution that's 25% acid. How many liters of each type of acid should she combine to get 10 liters of 40% acid solution? Okay? So what you do, and they kind of tell you, if I were to go back to the steps in here, what you want to do is let A equal liters of acid, probably, right? Liters of has another solution, 50%. Liters of, let's just call it X. Let X equal liters of 50% solution. And then you always have to set up variables, because you have to know what your variables stand for before you start. Okay, liters of the 25%, or not solution, acid, 25% acid, that should say, not solution. So I'm going to erase this and put acid. So what you're trying to do is figure out how much of each types of these acids do I need to mix. Like one's really strong, 50%, that would be very, very burning. 25%, that's pretty strong too, but not as strong as this. What you want to do is mix amounts of these such that your remaining amount is 40% acid. Do you understand? Like you maybe done swimming, right? And you see the guys in the swimming pool pouring chemicals into the pool. They're trying to get that a balanced pH level. Okay, so this might be an example where that might be an application. So what you do with all of these, you set X plus Y, that's equal to the total amount. That's really easy, right? Because however much you put in for X plus however much you put in for Y, that's going to equal up to 10 liters. Now what you also know is that the amount that I put in for X is 50% acid, okay? And the amount that I put in for Y is 25% acid, so I put 0.25 Y there. And that equals up to 10 also, okay? But it's going to be 40% acid. So that's the way you set these up, okay? First you just say, what's my total amount? So X plus Y equals that total. Then you say, you multiply the percent concentration of each thing that you're mixing, and then you multiply the percent that you want, which is 40%, times 10. You understand how to set that up? Okay. Once you have set it up, then the best way to do this, I think, would be using substitution. Okay? And so if X plus Y equals 10, what would Y equal to if I were to solve this equation for Y? What's Y going to be? If I bring this X over onto that side, what's it going to look like? How do I bring this X over onto that side? Subtract it, right? So Y is 10 minus X. Do you follow that? I subtracted X from both sides of this equation. And then I take that and I plug it in to Y. And then I'll have an equation that just has X's in it. Okay, 0.5X plus 0.25 times 10 minus X equals, what's 0.4 times 10? You guys know? 0.4 times 10? I'll give you a hint. It doesn't have a decimal in it.
It's 4.
4. Okay? 4. It's just 4. And if you didn't know that, use your calculator. Okay? Then you want to distribute just like we've been doing, 0.5x plus multiply this times this. That, I believe, gives you 2.5. And then you multiply this times this, which is negative 0.25x equals 4. And then you combine your like terms. So you have this and this. What's 0.5 minus 0.25? You have 50 cents to take away 25 cents. How much do you have left?
25 cents.
25 cents. So 0.25x plus 2.5 equals 4. And then you subtract 2.5 from each side, 2.5. And you get 0.25x equals 1.5. And then you divide both sides by 0.25, right? So I'm going to divide this side by 0.25 and this side by 0.25. And I believe that if you do that, you get x equals 6. Done? So it's not, the hard part is this setup. Okay, well maybe that's the hard part. I'm not quite done because I have to find y, but that's really easy because all I have to do is take my 6 and plug it into this nice equation. What's 10 minus 6? 4. Okay, and so you have, so equals y. So you have, you would use to make a concentration of 40%, you would put in 6 liters of the 50% solution and 4 liters of the 25% acid. Okay? You follow that? There's examples in your book. And on that handout, it also has pages where you would find similar examples. All right? So there's that one. Hold on a minute. I got to pause. I'm going to hide this. And here we go. So this is called a break-even problem, which we've kind of done before. Okay? And if you look on that, handout, it says the steps for doing a break-even number: assign the variables as x is the number of items being sold, and y as the money of the expense. First equation is your income. Second equation is the expense, and then use substitution. Okay. So first, I read the question. Suppose you have a typing service. You buy a personal computer for $1,750. On which you do your typing. You charge $5.50 per page for typing. Expenses are 50 cents per page for ink, paper, and electricity, and other expenses. How many pages must you type to break even? Okay? So let x equal, what should I let x equal? It says, let x equal being sold. So what's being sold? What's being sold in this case?
Pages.
Yep. Pages. Just pages in this case. Okay? Let x equal the pages. Let y equal amounts earned. Okay? Amounts. It should really say amount earned or spent. Earned or spent, because really what you're trying to do is make these two things. You want to see when the earnings is equal to the spending, and that's how they break even from. Skylar, focus. All right. So you buy a personal computer for $17.50 on which you do your typing. You charge $5.50 per page. So let's try to come up with a an amount for the y where this is your cost. How much have I spent so far? What are my costs? What do I have to buy before I can do this? Hello? What do I have to buy? You have to buy a computer for $1,750. Okay? And it also costs me 50 cents per page. So plus 0.50x. You follow what I did? Those are how much you, so you have to, initial setup of $1,750, and each page costs you 50 cents. The y, which is how much you kind of like your earnings, okay? Earning y is going to be, all it tells you is you charge $5.50 per page, so you call that X. You follow that? So you have one equation for your cost, which is 1750 plus 50X, and your earnings is 550X, because every page you sell, you're going to make, is that right? You charge 550 page for typing. Okay, that's a lot. That's a lot. You get rich doing it. Well, I guess it takes a long time. Depends how fast you can type. So then what you want to do is you want to see when these two things are the same. So really what you're doing when you do a break-even problem, you're doing a substitution. I'm going to substitute this y in for this y. Because what I'm trying to figure out is when your earnings is equal to the cost. So you're going to go 5.50x equals 1750 plus 0.50x. Okay? And you just solve that. Who can tell me my first step in solving this? What's my first step? Come on, Brian, what's my first step over here? You can tell me. What should I do to both sides? Subtract. Right, Karen? Karen said that. Subtract what? Yes, not 550. Subtract the 0.50x, because you want to take the smaller number away from both sides, right? Otherwise, you're going to get a negative number. Okay, so say subtract 0.50, you get 5.00x, or just 5x, equals 1750. And then it becomes an easy problem of doing what? Dividing by 5. So I divide both sides by 5. Okay, that's just 5, right? Divide that by 5. And I get x equals, this goes away. What is that? 5 goes into 17 3 times? 350. So, and the question was, going way back to the question, right? It says, how many pages must you type to break even? How many pages must you type to break even? 350. So if you type more than 350 pages, then you're going to be making money, right, on your investment. So that's the way that one works. What happened? What happened? How did that come up here? I don't know. So that's that. Okay. Last type of problem that we're going to see is a rate times time equals distance problem. And come on, close, buddy. Close. Close. Uh-oh. My video is malfunctioning. Something's wrong. Well, first we have to pause. And we're going to try. So this is whenever you see things flying around, it's a rate times time equals distance problem. Do you guys know that? Rate time, have you heard that? Rate times time equals distance? Good. So rate times time equals distance. This is how you set up these problems. What does it say to do? It says Mrs. Moss's worksheet. It's called the headwind tailwind. It says write an equation, a minus w times some time, and a plus w. Oh, it's a headwind tailwind problem. Okay. So suppose it takes you 6 hours to fly from Miami to Florida, Seattle. At the same time, your friend flies from Seattle to Miami. His plane travels with the same average speed, okay? But his flight takes only 5.6 hours. Find the airspeed of the plane by the average wind speed. So what you want to do in this is let A equal the airspeed, and let W equal the wind speed. And I teach this same thing in my advanced pre-calculus class. And kids, even though it's relatively easy, once you know how to set it up, kids still get it wrong. It's knowing how to set it up. Okay? And so, like, have any of you ever flown from like here to California? Okay? Is it faster going there, or is it faster coming back?
Going there.
It's faster going there, right? I think it is. It's like half an hour less. And the reason is because you're flying with what they call the jet stream, right? Which is a current of air that's way up high, that's kind of pushing you as you go. And then when you're coming back, you're flying against the jet stream, so it's kind of pushing you in your airplane, so you're going slower, right? So it takes slower, it's a long time, and then if you're going to California, it's way faster too, because you have daylight savings time, right? So you're saving, or because the time zones are different, so you're actually gaining an hour, and then when you come back here, you're losing an hour, right? Yeah. And same in New York, I fly in New York a lot, you lose like 2 hours. And it's slower going there because the jet stream, I guess, is going against you going to New York, and it's going with you. So it's almost like 2 hours or an hour and a half difference when you fly from here to New York going than when you come back because the wind is pushing you. So the way this works, okay, rate times time equals distance. So your rate when you're going with the wind, A plus W is your speed with the wind, because you're going to add, this is like what you want to do is call this is your going equation, or with the wind, or going with wind. Okay, so you have A plus W times the time. How long does it take you when you're going with the wind? 5.6 hours. Should take you less time, right? 5.6. So you got to make sure you plug in the correct numbers, right? Obviously, if it takes you less time, then you're going faster, right? So then you have A plus W equals, and then you could get a root beer if you're going to A plus W, right? A and W, that's root beer. They still have AW here down the street, right? Is it still in business?
Yeah.
At A&W? Yeah, is it? In Louisville?
Wait, what?
I've seen this in New Jersey.
Wait, what?
There used to be an A&W right
One in
there.
New York.
Yeah, it was a Slippy.
Yeah, it's
Yeah.
the Lapeeps.
I'm sorry. Okay, I didn't like it. I never liked it. Okay, shut up, Mr. Get to work. Okay, this is, so the distance is the same in both cases, 2,800 miles, okay? And the distance in this case, what do you think you do if the wind is going against you? What do I do with that W? It's A plus W going this way. What's your speed going to be coming back? Or A minus W. That takes you 6.8 hours, but you're still going the same distance, which is 2,800 miles. Do you follow that? Yeah? No? Okay. So now the way to solve this, you could distribute and then try to use elimination and stuff like that. But the best way, this is kind of a trick here, okay? What you want to do is take this equation and divide it first by 5.6. And I'll show you why that works, okay? So I'm going to take this and divide everything, this is going to be hard to do, by 5.6. Divide that by 5.6. Okay, and when I do that, I get A plus W, because that'll make the 5.6 go away, equals, Justin has his calculator, hurry up.
500.
How much?
500.
Wow, that's a nice even number. A plus, so they try to make these problems so that they work out. You guys see what I did? I divided everything by 5.6. What do you think I'm going to divide by in this equation? 6.8. So divide both sides by 6.8, divide this side by 6.8, and then I get that equation turns into A minus W equals 2,800 divided by 6.5. What do you get?
411.7647.
Seriously? What do you get? Try it again.
411.764705.
411 point something? Point what?
0.76.
0.76. Okay. So, who can tell me how I get rid of one of the letters? Easy. What do I do with those two equations? Add them together. Okay? Just add them straight together. That gives me 2A equals, this goes away, 911.76. And then I divide by 2, and I get the airspeed is What's that, Justin?
Um,
450,
55.88.
455.88. That's going. And since A plus W equals 500, then I could just take that A and plug it in there, and I would get that the wind is going about 44.12. Is that right? 44.12. Is that right? If I add those two things together, I think I get 500. All right? So 450, if I subtract 455.88 from 500, I should get 44.12, right? I do.
Yeah, yeah, 44.
Okay, so this is how fast the plane would travel in still air, and this is how fast the wind is blowing along. Okay? So your homework, which we're going to start, and I'll go over a couple of those other problems, is page... I didn't even look at my notes. Is page... and we're going to spend another day on this on Tuesday. Page 365. Don't worry, it's not like 20 problems. Look, stop doing that. Why is it doing that? Stop doing that. Homework, page 365. Number 1 and 365. That's what I mean. 3. I said one thing, all right, something else. Page 365, 1, 3 through 6, yes, and 16 and 18, and that's it, okay? So it's not all that much, right?